Okay guys, congratulations, you made it to your second lesson. We're going to continue looking at comparing and ordering rational numbers. So we're going to keep working on demonstrating an understanding of rational numbers, and we're going to keep comparing them, and we're going to keep ordering them. The new thing this lesson that you should be able to do is identify a rational number that is in between two given rational numbers. So for example, if I gave you 2 and 3, they're both rational, you would need to come up with a value that's rational that is in between those. So we're going to practice that today. Before we move on to anything new though, I have some reminders for you, some review from lesson 1. So this first example asks you to write the following rational numbers in descending order. So I'd like you to take a minute and figure out, maybe put them all into decimal form and then put them in descending order and put them on the number line, and then we're going to check your work. So I'm going to pause this so you can do that. Okay, so hopefully you put all your fractions into decimals by going numerator divided by denominator. So 3/5 becomes 0.6, and that's 0.60 or 0.600 if you want to think of it that way. And then we have -5/8, which becomes -0.625, so it's rational because that decimal ended. Then we have -0.6 repeating, 0.72, and 3/2 or 3/2, which is the same as 1.5. So we need to put these on the number line, keeping in mind that if it's an exact value, I'm going to put an exact dot, and if it's an estimate, I'm going to use an arrow to show its approximate location. So if we go down to the number line, your number line should look something like this. Okay, and so just going through these examples, when we compare -0.6 and -5/8, -0.66 is a larger decimal, so 66 is greater than 62.5 or just the 62, and so it's going to be closer to -1. If we thought of value, -0.66 would actually be the lesser value because it's further to the left. Okay, and then when we look at the other two decimals that are close to each other, so 3/5 was positive 0.6 and then 0.72, so 0.6 is closer to 0.5, and then 0.72 comes after, so 0.50 cents, 60 cents, 72 cents if we're thinking of money. 3/2 is exactly 1.5, and so we can put a dot there instead of an arrow. So if you look back at the top of the question, it asks you to put them in descending order, which means largest to smallest. So I'm going to read my number line looking at the right side first, because those are the larger values. So 3/2 is the largest, then 0.72, 3/5, -5/8, and then -0.6 repeating is the smallest value. The next little bit of review from lesson 1 that I would like you to do is use equivalent fractions to decide which rational number is the smallest. You may also use a decimal method, but I would like you to practice using the fraction method just because most of you tend to struggle with it. So I want you to pause this and try to figure out which value is the smallest value, keeping in mind that smallest means furthest to the left on a number line, and then you can check your answer. So pause it, solve it, check your answer. So if we look at example A, the easiest common denominator we can make is 10. So if we took -3/5 and multiplied both the top and bottom by 2, we would get -6/10. So we could compare -7/10 and -6/10. If you didn't notice that 5 could be turned into 10, you might have multiplied the denominators by each other. So 10 times 5 and 7 times 5, giving you -35/50. And then -3 times 10 and 5 times 10, giving you -30/50. Either way, we're looking for the value that is smallest. So we're looking at negatives. We're thinking farthest to the left. So -7/10 or -35/50. These would be the smaller values because they would be further left on a number line. If we're looking at the second example, I started off by taking your taking your mixed numbers and turning them to improper fractions. So the way that we do that, 5 times 1 is 5. Add the part on top, gives us our new numerator, so 6/5. Same thing on the right. 9 times 1 is 9, plus 2 is 11, 11 over 9. So we don't have the same denominators, we can't compare them, but we can multiply the fractions by the opposite denominator in order to compare. So we go 6 over 5 multiplied by 9, giving us 54 over 45, and then 11 over 9 times 5 to give 55 over 45. So this one, again, 54 pieces or 55 pieces. 54 pieces is the smaller value. If you struggled with this, make sure you see me tomorrow so we can do some more lesson 1 practice before we move ahead. All right, so this is your first new example for this lesson. And this example is asking you to find a fraction between the decimals negative 0.6 and negative 0.7. So if we think of these two values, just on a number line, we've got 0 over here, and then let's say that this is negative 0.5, and this is negative 1. We have negative 0.6, and then negative 0.7. So we need to think of something that's in between. If you think of a ruler, if you look between the centimeters on a ruler, right, if we go 1, 2 centimeters, we can't see anything smaller if we're only looking at centimeters. We need to go to the next smaller unit of millimeters. The same thing is true when we need to find a value in between two numbers that appear to be consecutive or right after each other. So 0.6 and 0.7 appear to be right after each other. The best way to find something in between them is to go to the next decimal place. So to think of this as negative 0.60 and negative 0.70. Well, now that we think of them as 60 and 70, you should hopefully think of 9 other numbers that come in between them. Take a minute, think about it. Okay, so hopefully you came up with a decimal like 0.61, negative, or negative 0.62, negative 0.63, negative 0.64, 65, 66, 67, 68, or 69. Okay, are you done giggling? Good. Pick one of those decimals and we're going to turn it into a fraction. Now, we want to pick a value that is a rational value. So we need to think of decimals that would make rational values. Now, in this case, all of the fractions we would pick would be rational because we're starting out with decimals that are rational. But it might not always be the case, so just be careful of that. So you can pick any of those decimals you like, and we're going to put them into a fraction. So I'm going to pick 0.64, just because. And so negative 0.64, I'm going to put the decimal into a fraction, and I want to think of what decimal place am I looking at. So we have tenths, and then we have hundredths. So I have 64 hundredths, or 64 hundreds. So negative 64 out of 100. If you are somebody who's working at a pretty basic level, that's as far as you might get. But for the rest of you, I'm expecting you to realize that both of these values are even, and this fraction is not in lowest terms. So I want you to think about how you would turn that fraction into lowest terms. So you would either look and see, okay, both values are even, so they both can be divided by 2. So we're going to divide by 2, and we get 32 over 50, and it's still negative. Okay? Again, I hope you realize that both values are even, so we're going to divide by 2 again. And we get negative 16 over 25. Now we have one even value and one odd value. So then I would think, okay, do both values, can I divide them both by 3? No. Can I divide them both by 4? No. 5? No. 6, 7, 8, 9. They don't have a common multiple. So this would be our fraction in lowest terms. And this fraction is between negative 0.6 and negative 0.7. If you don't believe me, type it in your calculator. You should get negative 0.64. Again, if you picked a different example, you're going to have a different decimal, but it should be in between our two rational values. So there are 4 more examples here of finding a rational value in between two given rational values. I would like you, if you feel comfortable, to give these a try before watching the rest of the video. If you feel like you're struggling, maybe watch 1 or 2 more examples and then try the others on your own. I'm going to do A and then C, so that way you see a decimal and a fraction example, and then I will do B and D. If you want to give this, if you want to watch 2 examples first, you'll see a decimal and a fraction first. So again, when I look at 2.4 and 2.5, they look like consecutive values, one that comes right after the other. But if I put them at negative 2.40 and negative 2.50, well, now I have a range of values in between. Thinking of money, I could have 241, 242, etc., all the way up to 249. So I can pick any of those values. I'm going to pick negative 2.45. It's in the middle. It's nice. So again, I think, okay, what decimal place do I have? And we have to the second decimal place, which is our hundredths. So we have negative 2 and 45 hundredths, right? Remembering that a number in front of our decimal is a whole value, so we don't need to put it in a fraction, it's a whole value. Some of you might get to this only this point. Some of you might realize that 45 and 100 have a common multiple still, so I can divide both of them by 5. When I divide both top and bottom by 5, I get negative 2 and 9 over 20. This fraction is in lowest terms because 9 and 20 do not share any common multiples. So that's your decimal example. Let's look at a fraction example now. So negative 2/3 and negative 4/5. In order to find a fraction that's in between them, we need to have our fractions in a common denominator. So again, I could look at multiples of 3 and multiples of 5, or I can do kind of the quick cheat way and times the first fraction by 5 and get negative 10 over 15, and multiply the second fraction by 3 and get negative 12 over 15. Well, 10 and 12, I know what comes in between 10 and 12, or I hopefully do. If not, let's practice some counting. And in between negative 10 and negative 12 is negative 11 over 15. So now we have a fraction in between our two given rational values. So I would encourage most of you to pause it at this time, try B and D on your own, and then check back for the answers. Example B, we need to do the same trick that we did with example A. In this example, the only difference is we're going to the thousandths, so the third decimal place. We can keep adding a 0. That's not going to affect the value. There's still 52nd hundredths there, and there's still 53 hundredths there. We haven't changed the value. All we've done is we've added another decimal place, so we can think of something that comes in between. So I picked 0.526 just because I can. And so to put it into a decimal place, we look and we see tenths, hundredths, thousandths. So we put it over 1,000, 526 over 1,000. Or if I'm going to lowest terms, I divide both by 2, and I end up with 263 over 500. Now this is kind of an ugly number. I would want to keep try dividing both top and bottom by 3, by 4, by 5, all the way up to 9 or 10 and see if I can get any further. Otherwise, we would assume that it can't be reduced any further, and it is. 263 over 500 is lowest terms. If we look at our last example, I put both fractions into improper fractions. So 3 times 1 plus 1 gives us 4/3, and 7 times 1 plus 5 gives us 12/7. Again, we still don't have a common denominator, so just like example C, we need to make a common denominator. The way that we do that is multiplying the fractions by the opposite denominator. So for 4/3, we multiply top and bottom by 7 to get 28 over 21. And on the right-hand side, 12 over 7, we multiply top and bottom by 3 in order to get 36 over 21. So now I can pick any value in between 28 and 36 and put it over 21 and have a fraction that's in between them. So I chose 30. And 30 over 21 is the same as 1 and 9 out of 21. 9 and 3 can both be divided by 3. So lowest terms becomes 1 and 3 over 7. So that is your second lesson completed. Again, we have some practice questions. If you struggled with any of the first examples, I would encourage you to do some more basic practice before you move on to these 3 questions. Otherwise, we will have time to go over these in class tomorrow.